Hi, hello everyone. So what we're going on to this week is something. For most of you, it's going to be a lovely subject. I personally like it, and we're going to use a lot of the skills we've built up, and it's probability. And probability is the mathematical study of. It's the study of chance. Okay. So what do I mean by chance or probability? Well, it's the chance of something happening, or the probability of some event occurring. So let's get some of the words out of the way first of all before we go into the possible. So an event. Okay, in maths, an event is something that happens. E.g., flipping a coin, rolling a die, turning a spinner, you get the idea. Okay, it's the actual action of doing it. It's the event. Okay, the outcome is the result of the event. So here it's going to be heads or tails. It's going to be 1 or 2 or 3 or 4, 5 or 6. Or if you're turning a spinner, it's whatever's on the spinner. So look, for example, here's a spinner. As you can see, it's got 4 possible outcomes, 1, 2, 3, or 4, depend. So an event would be spinning it, and then an outcome would be it landing on a particular number. Okay, same with the dice. Okay, I roll the dice. It's a 5. Okay, so the event is rolling the dice, and the one I get is the outcome. Okay, that's the basics of it. Okay, so if you're asked to list all the possible outcomes, well, what's the only possible outcomes you can get from a die? It's 1, 2, 3, 4, 5, 6. If you're asked to list all the possible outcomes from flipping a coin, there's only 2 possible outcomes, heads or tails. And if it's asked to do a spinner, well, it's how many possible different things can the spinner land on. Is it a one? In this case, there's 4 possibles: 1, 2, 3, or 4. So that's listing all the outcomes. Okay, so where we get some help on this is this all feeds into a branch of maths. Okay, and into something called the fundamental. Don't be scared of the word. Principle of counting. It's a very, very important piece of kind of mathematical rules. Okay, so how does it work? I'm going to do it in the most basic possible. Okay, if one event has I'm going to use a general version, and then I'm going to make an just to show you. Okay, has m possible outcomes, and another event has n possible outcomes, then the 2 events happening have m multiplied by n possible outcomes. Now, you don't have to learn this off, but I'm going to show you how simple this is. I'm going to change color here. So what does this mean in terms of, well, let's take 2 examples. Let's take our die, and let's take our cent. Okay? So there are two, if one event, the event of flipping a coin, has m possible outcomes. So flip a coin has two outcomes. Okay? Roll a dice. Roll a die has 6 outcomes. Possible outcomes. Sorry. Should have put in the word possible. Okay, but you get the idea. So if that has 2 and that has 6, then there are, and this is the important bit, there are 2 times 6, which is 12 possible outcomes of doing both of these things at the same time. Now, what does that mean? Well, let's just see what that means. Okay? Let's see what that means. So, what's the chance of me throwing a die? That one needs to go on Instagram. Okay, I flipped a coin and it landed on its edge. Right, so you flip a coin. Okay, it's a tails. Okay, and you roll a dice and it's a 4. So the two events happened, and there is a possible outcome. You get a tails with a 4. Let's say I did it again, but I got a tails with a 3, then a tails with a 2, then a tails with a 1, then a tails with a 5, then a tails with a 6. That's all the possible outcomes I could get if I flipped the coin and got tails and rolled the dice. Because you can't get more than 7 when rolling a dice, or rolling a die, and you can't get any other thing you can possibly get. So that's all the possibilities, okay? So you can get a tails with all of them. But what happens if we'd flipped and gotten heads? Well, I could have also gotten heads with 6, heads with 5, heads with 4, heads with 3, heads with 2, and heads with 1. Now, if you remember back to our previous sheet, what did we say? We said that the fundamental principle of counting says that if one event has m, in other words, flipping a coin has 2 possible outcomes, rolling a dice has 6 possible outcomes, then the two of them happen and together would have a total of 2 times 6, which is 12. How many outcomes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Okay, now it doesn't look nice that way, does it? No, it would be a lot easier if I put this into a nice little table. Just so people could see. So that's a heads with a 1, a heads with a 2, heads with a 3, a heads with a 4, a heads with a 5, and a heads with a 6. So tails with a 1, tails with a 2, tails with a 3, tails with a 4, tails with a 5, and tails with a 6. So that looks a lot neater because now you can read across. So across here, okay, so this is going to be, what are these? These are die. And what are these? These are coin. So there's the outcomes from a coin. They're the outcomes from a die. But when you combine them, you get these 12 possible outcomes. Okay? So that's where this comes into play. So we'll do another example. Okay? Pizza Hut. Oh, sorry, Domino's. I'm not sponsored by Domino's, but if they want to sponsor me in this video, they can. Domino's has 3 possible bases. It has 2 possible sauces. It has 12 possible toppings. And it has 2 possible cheeses. Not including cheese topping, because if you don't have cheese in a pizza, it's not a pizza. I don't care what anyone says. So, how many different pizzas could I make? Well, what does the fundamental principle of counting says is if you have something, some event, and you know the number of possible outcomes, multiplied by another event with its possible outcomes, multiplied by another one, multiplied by another one, then the total possible outcomes for all those things, if you have to pick one from each, is actually going to be 3 times 2 is 6, times 2 is 12, 144 different types of pizza you could pick. And I'm pretty sure there's more options than that in Domino's. Definitely is, if you want to make your own. Now that's a crazy amount with just 3, 2, 12, and 2. Okay, so there's a lot of different outcomes there. Okay, so that's the basis of the fundamental principle of counting. It's a very important thing. Why is it important? It's important because it gives you the ability to find out the total number of possible things that could happen when two or more events happen at the same time. Okay, so, and that is quite important because when we come on to do our probability, okay, we need to be able to express our probability, the chance of something happen in terms of the chance of all possible things of happening. Okay, so it's important we build up this base. Now, the math is very easy, as you can see, but it is really a matter of you just taking your time with it. So let's do a couple of examples just to get you going. Okay, so a menu has 3 starters, 4 mains, and 2 desserts. How many different meals can you have if you pick one of each? Okay, so you have 3 starters, 4 mains, and 2 desserts. I'm going to count from 3, 2, 1 and see, can you give me the total number of outcomes that there could be? So 3, 2, 1, go. Right, here we go. So what does it say? The fundamental principle of counting states that if you have an event, so the starter is an event, okay, and you have the number of outcomes for that event, and then you have a second event, the mains, and you have a number of outcomes for that, and you have another event, the dessert, and a number of outcomes from that, then if you multiply the 3 outcomes, 3 times 4 is 12. That's 24 possible meals you can if you pick one from each. So the poor old chef has a lot of work to do there, different combinations. Okay, I hope you got that. Right, here's another one. Man rolls a die and spins a spinner. How many possible outcomes and list them all? So here's my spinner. As you can see, there's 4 sides to it. 1, 2, 3, 4. Here's my die. As you can see, there's 6 possibilities on the die. So my question to you is, can you work out how many possible outcomes doing these 2 things at once? For example, one possible outcome could be 4 and a 2 on the spinner. Another possible outcome could be 1 with a 4 on the spinner. But how many possible outcomes could there be? And then can you list all those possible outcomes? That's a tougher one. Okay, listen them, probably do it in a table, do up a table, it'll make more sense. Okay, so 3, 2, 1, go. And we're back. So, hope you got it. So, fundamental principle of counting states that if one event has 4 possibles and another event has, yes, you're right, 6 possibles, then the 2 events have 24 possible outcomes. Now, the question is, can you list them all out? Okay, so this is where it's going to get a little bit fun. So, how do we do it? Well, let's do a table. I have 4 possibilities. So there's 1, 2, 3, 4. I have 6 possibilities. Let's do these in a different color. Okay, 1, 2, 3, 4, 5, 6. Okay, so you can see it's a big table, but why is it a big table? Because there's 24 possibilities. Okay, let's fill it out. I roll a 1 and the spinner comes to 1. Not like that. Roll a 1 and spinner comes to 1. So you had a 1, 1. I roll a 1, spinner comes to 2. So that's 1, 2. Roll a 1, spinner comes to 3. 1, 3. Roll 1, spinner comes to 4. 1, 4. Roll 1, spinner comes to 5. 1, 5. And then 1, 6. And you can see what's happening. You can just fill it up as you go along. 2, 1, 3, 1, 4, 1. What's this? 2, 2. 2, 3, 2, 4. 3, 2, 3, 3, 3, 4. What's this one? 4, 2. What's this one? 4, 3, 4, 4. 5, 2, 5, 3, 5, 4, 6, 2, 6, 3, 6, 4. Okay. It looks a bit tedious, but you're getting really good practice, because when we come on to probability, knowing this set of outcomes will be very handy to know. Trust me. Okay? So, one more and then we leave it. Right. Right, here we go. What happens if we have more possible outcomes? Okay? So, imagine if I asked you to flip a coin 3 times. Okay? So, let me see now. We have 3 coins. So, I don't have 3 coins, I have 2. But imagine a third one there. And we're going to flip all 3 of them at the same time. Okay? So let's put this down in English and then we'll see. Okay? Let us see. Let us have 3 coins are tossed. How many outcomes? And list them. Okay, do you know what we'll do this time? Let's this time instead list them all first and then see, does the list tally with the maths we'll do afterwards? Okay, so let's list them. First of all, let's say they're all heads. Well, let's just write down 3 heads. Okay, and then let's say you get 2 heads and a tail. Okay, and then you get a head and 2 tails. Okay, and then you get a tail and 2 heads, 2 tails and a heads, and then all are 3 tails. 1, 2, 3, 4, 5, 6. Now, does that tally with what we know? How many outcomes are there from the first coin? 2. How many outcomes can there be from the second coin? 2. How many from the third coin? 2. Multiply them together, you get 6. Do I have 6? I do have 6. Okay, so the maths matches the reality when you put all the combinations together. Okay, so that's your starting introduction into probability. There'll be some questions on this, so best of luck. Okay, thank you, bye.